Welcome everyone. This is Daniel Paez, and today I'm going to talk about the first week, the introduction week of IT3030 individual projects and IT3090 group projects, which is the subject that we have combined for your software projects, software development projects in UHD. Today, this is a course that has both individual and group projects. It's for the bachelor, your third year. The duration of the project and of course of the subject is 1 semester. This is a face-to-face subject, and as I mentioned, my name is Daniel Baez. So what are the objectives? What are you doing this course? So first, in the first 5 to 10 minutes, I introduce the course, and then I will give you the first lecture about this course. What are the key things you need to know? And this is a very important lecture because in here, I am going to present to you one of the most advanced methodologies to develop software, which is the expectation we're going to have and how we're going to align this with the assignments that you have to present. So IT3030 develop an individual software project from start to finish. IT3090 work in teams to manage and implement a software development project. The difference between the two is that in one, you're going to practice develop a project as a group. And this is very important. You have to do a larger project, of course, because it's a group of you. And we're going to practice how you put projects together. When we do software development, what's the difference between a project that I'm doing by myself as a sole developer compared to a project that I'm doing as a group? In this project, we gain hands-on experience in project life cycle management. You have to produce something that is industry standard, and we're going to have industry partners. They're going to be people for industry. They're going to check with you to make sure your projects have a relation to the real world. This is not a subject with a theoretical base. This is a real subject in where we're going to work in the development of real applications. Now, let me tell you about myself. I'm originally a civil engineer, but I'm very passionate about software development. I work in the geospatial area, means surveying, doing things with maps, like geographic information systems and so on. I have multiple applications I have developed. At the moment, I have one that is very interesting, which analyzes with AI the rulings from the court about urban planning. And I have experience with government, private sector, and international organizations. And I'm going to use these experiences so you can actually have a real experience in the industry in this subject. And I'm an active lecturer and research. I also lecture at Swinburne University, and I work in a local government as a contractor. So I have that ability to bring to my classroom the experiences from industry, and I hope to share it with you. Now, how we are going to assess that you can complete this subject and demonstrate you can develop an individual or a group software project. You're going to have 5 assessment points. They're going to be in week 3, 5, 7, 11, and 12. There's a gap between 7 and 11 is the important moment to develop software, and in 12 you're going to do the final presentation and report. Now, I'm going to explain a little bit more the linkage between the development strategy, the rapid development strategy we're going to follow, and the assessment. But let's start with the assessment. They're going to be in week 3, a 5% assessment. That is your project concept. In week 5, project proposal. But keep in mind here, you're going to do requirements planning. And then in week 7, you're going to have 20% is user design with planning. In this one, we do piloting. You need to go and run code and make sure it's working already. In week 11, we do software demonstration, and in week 12, we do final implementation report. This is incremental. I'm going to assess you not just on the final product, not in the initial concept. It's incremental, and that's why we have multiple points of marking you. This is all described in your subject outline that you can check in the LMS or Moodle. Now, other additional course information, remember minimum attendance. This is a face-to-face course, 80%. You have resources, the computer lab, project management software, programming tools that you want to use. We're going to discuss some of the free ones. You can actually access online. You can use some of those in your computer. I want to start seeing best practice in using tools, latest tools. I don't want to see basic old style tools. Remember, I'm going to follow the project. We're going to have a little bit of lectures that are very specific in concept, like this recording, but at the classroom is hands-on. Bring your machine, bring where you're developing your software. We're going to work on software directly on what we're doing. Now, there are important dates that you have to submit. The assignments are normally the Friday at the end of the week that we are working. So you will have the Friday that you have to work on the week and the Friday. You need to plan it in advance. Remember, the key assessments are 3 weeks 3, end of week 3, end of week 5, end of week 7, end of week 9, big assessment, and end of weeks 11 and 12. So there is multiple moments in your where you have to be presenting your results. And I'll tell you in a minute why that is so important. Now, this is the first week, so now I'm going to introduce the software project. Some of these things you have seen already in your career, but I want to consolidate it because what I want to see is the development of a software that is industry ready. Remember that word. We want to see a software that you produce that is industry ready. So to be able to do that, the first thing we're going to do is the definition of software project and their life cycle, the difference between individual and team software projects. What are the differences and why a team can develop a larger, more complex project, and the importance on the structured project planning and management. They are connected, the life cycle to project management, and this is very important, and you need to demonstrate that you can connect them through the assignments. That is an important part of this subject. You need to select a project, and the best project you can select is something that you are passionate about. This is an academic exercise, so it's not going to be released in the market for production, but the quality is that I'm expecting you to do is industry ready, that you are actually able to release it if you want it in the future. So when you go out there to find a job, to do your own company, whatever you're doing in the future, you have something to show and you can demonstrate that you have worked in a project that has significantly developed software skills. Software development skills are shown with the application that you have seen. I've shown you some of those in my lectures. So the first is the project that has to be about your passion. I would play a role in helping you and give you your industry context. You can have your own context if you perhaps decide to work overseas or the World Bank international context, which I have. But the important thing is that we have to be in communications, and the assessments are the expected deliverables and documentations. So if you want to know how you're going to demonstrate that the software works, is not just the demonstration in week 11. Is also bringing evidence that you have consulted with the industry partner, that you are using the best standard in the development of software. I'll give you an example. In Geospatial, we use JavaScript significantly, but we need to understand how it's implemented in the core libraries that are for geospatial analysis, like those in QGIS, which is a software that does it. So yes, we use JavaScript and sometimes TypeScript, but whatever we use is underpinned by that. Also, what is going to be your underpinning platform? I want to start seeing software that is developed in React, or if it's a website, perhaps it's developed in Astro. The more advanced methodologies for software is what I want to see here. I want to start seeing very sophisticated development with the help of tools, and we will work through those as part of our lecture. Now, project management. You, as a team member or as individual project, you need to do project management. That is something that needs to be part of your task. You have to do that. That is no excuse for that to do it. So from day one, once we start looking into which is the key project you want to work on, you need to start thinking in key components: planning, execution, monitoring, and closing. What tools you're going to use? It's a Gantt chart, it's a agile board, software development methodologies. You need to start thinking, what are we going to do? As a minimum, I want to start building with you for by week 2 a Gantt chart and the agile boards, because we're going to have a component for an agile. We will see that in a minute. And important is how we are putting in our Gantt chart those milestones of assignments 1, 2, 3, 4, and 5. How we fit if that was the deliveries of our client. I want to, as a project manager, you keep timesheets of the effort that you're putting, where you put in the effort, and how is that being spent. Everyone has to present every week the timesheet, how they've been using the software. Get used to it. As a software and as an IT expert and future professional, you have to demonstrate how you use your time and how long it takes you to do things. And you're going to start doing that in this subject. Now, you have seen this. This is a third year bachelor's degree. I want you to be very, very solid on the software development lifecycle. You need to understand this before we start development of software. What is this, the cycle? We do planning. What are we going to do? We analyze if our planning works. We design our solution. What stack we're going to use, where we're going to develop, where is going to be the database, how we're going to connect, what is the sandbox, the testing methodology, and so on. We do implementation, and then we test it. We deploy it to a production server under a testing environment. We release alpha, we go into beta, and then we maintain it when it goes go live. So this is, and then we go back again and said, oh, we're gonna release this next version and so on. So that's why you see beta versions. So when they give you a beta version, it's because you're part of the version that is in number 5, testing. And if you get access to 4, step 4, you are in alpha. Alpha versions are the ones that have been implemented. A lot of bugging, a lot of challenges, and so on. And you can you are working with very raw code. In beta, is a pre-production. In maintenance, we are already in production and maintaining the code, and that's the patches that we produce, incremental. Now, they are basically, you need to know by now that they're basically 2 strategies to develop software. You do waterfall, in where you put extensive requirements by the stakeholder, your actors, your client, your investors. They design that, you check the design, and then you go and write the code, verify that works, and maintain it. Very commonly used, still used in big corporations that changing things is hard. For example, banks. Banks will use waterfall. They cannot change constantly the software. But Google, Facebook, and so on, they use a combination. Sometimes in some projects might be waterfall, or in others, agile. So the alternative to waterfall is agile. In agile is hypothesis driven. So you go and plan for something in the software, and you do a mini life cycle: design, develop, test, deploy, review, and launch. And you have sprints because all the energy is put in those sprints. They go around and develop. Very important here. For the group assignments and for the individual assignments, I'm expecting to see agile sprints in the testing. For the group assignments, I expected to see parallel sprints. In other words, there's going to be a scrum master who is going to run multiple sprints. Every individual member of the team run the sprint with code writing aids, bots, and so on, and then they put it together to the stakeholder with the help of the scrum master. Minimum, we're going to do it twice. Minimum, we're going to do this twice. And that means that you're going to have the opportunity to be in the sprints as coder and in the and combining all those code into be a scrum master. Very important that we learned in we working on as a project how we put code together. As an individual project, you need to be able to show that you can do sprints. And minimum, you have to have the ability in this semester to do 2 sprints, minimum. But how I'm going to assess it, I'm not going to use just waterfall or agile. We're going to use something that's a little bit hybrid. In some literature, they call it a cyclone or an alternative. I'm going to use the one that is called rapid application development. You're going to see this in multiple parts. I'm sorry, my image is is obscuring the last part of the table, but that is assignment 5, the report. So rapid application development combine both. It's a waterfall that moves into a well-developed project, but has a prototype cycle. In other words, before I go into full production, I do a prototype cycle. And that cycle contains multiple terms, and that are the sprints. So we combine the waterfall steps, requirements, testing, implementation into agile in the middle. Minimum 2 cycles of prototype development. And the code that I'm expecting to see is a code that is operational. And the prototypes needs to be demonstrated. So in the assignment 1, you're going to do analysis and quick design. And then in assignment 2, you prepare your prototype cycles. Assignment 3 and 4 are those cycles, and you demonstrate the results of those cycles, prototype cycles. So in assignment 3, minimum 2 cycles. In assignment 4, you might bring that into the what have you learned in the cycles to develop production and start showing testing and demonstration. Assignment 5 is your reporting. In assignment 4, you present the software to a panel that includes industry members, and assignment 5 is the final report that we assess from the point of view of report writing and documentation of the software. This subject, it is not an academic exercise. I want to see software that is developed, and this is what we use in industry. When you are given a task, you need to choose, what are you going to choose? Waterfall, you're going to use agile, or rapid application development, which is a combination of both. You can see there's a cycle in the middle that is agile. This is what I'm going to start seeing, and this is what we're going to do this semester. Very good. Now, a little bit more theory. We're going to practice this in our first week. Those 3 hours, we're going to spend them in consolidating this and start exploring what is important for you. But the project planning and feasibility study, we're going to identify requirements and definition goals, conduct a feasibility study, and write an initial project concept paper, which needs to be delivered in week 3. That paper needs to contain what you're doing, what problem you're trying to solve, what is your industry partner, and how you plan to address that design. A feasibility study, basically, you can do multiple types of feasibility. You can do technical feasibility, which are expected. Economical feasibility, in your case, is the number of hours you're going to spend in this. You know, you have 9 hours of your own time per week to be spent in this subject, 3 plus 3 hours that we do in class, so you have 12 hours. And operational feasibility, how you're going to implement this, where you're going to test it, and so on. There's other ones like legal feasibility and schedule feasibility. If you have multiple software, you can imagine, for example, a bank has the software that manages the accounts, the other one, the software, the international transfer, the other one that works online, the other one that is the application on the mobile phones. We're not doing this. So we're focusing on the top, the 3 ones: technical feasibility, economic feasibility, number of hours you're going to develop, and operational feasibility. Those 3 things I want to see. Now, what is the interaction between feasibility and requirements? Requirements is what is the software means supposed to be technical requirements. This diagram we're going to look into more in week 2, but look at feasibility study. I do my first report, which we'll do probably by week 2, and then you start changing those requirement analysis to do the system models and requirement documentation. But there is cycles, because that's why we do the prototyping. We change the requirement analysis and change the requirement definitions, change the requirement specifications. We start changing, and then they affect one and the other, and they go different feedbacks, and so on, until we are in a moment at the end, the diagram down here that you can see. In this moment, I know when I'm here at the bottom of my page, the specific requirements have gone through cycles that tells me if I can do that. Once I have that, I can go into the requirement documentations. It is a cycle. That's why you do the pilots. And that's why I want you to learn state-of-the-art, best practice, best world practice in software development. Now, those days that it will do something and design it very well and precise, and they produce it and then hope that it works, are gone. We now can test things before, and this is what I want you to do. I want you to start running code from week 1. You need to go and test libraries. You tell me that if you tell me you haven't heard about React as a stack to develop software, go and test it. If you tell me you haven't heard about Astro and many other methodologies to develop software, I want you to go and test it and try it. Piloting is part of a project. Every project and the clients expect you that before you make massive investments in code writing, you have tested many of the components of that code. Very good. We're wrapping up now. 2 slides more to go. Now, you need to start thinking how you're going to manage the scope and stakeholders. Yes, the scope of the group project is larger, but that larger scope needs to be realistic. I will try to help you that, but you with your planning needs to start learning what is realistic or not in the next 12 weeks. So in understanding project scope and avoiding scope creep is fundamental. Now, who is your stakeholder will depend on your passion. We'll talk about that in week 1. You're going to tell me what industry you want me to put you in contact with, what industry you already know and you want to work with them, and so on. This is industry-ready projects. So we need the input from them. They need to get on the phone. You need to go and visit. You need to be able to do something that is effective and efficient for industry ready. And in that, how are you going to communicate? How are you going to communicate with your software supervisor development, which is me? How are you going to communicate with your stakeholders, which are the users? How are you going to communicate with your client, which is the industry partner? How are you going to communicate with your team if you are in a group team? Those things we're going to discuss it on the first week, and I would like to see results from first day that you have a strategy, that if it's phone, that if it's WhatsApp or whatever, you have an ability to do it. Now, adding to the final one that I add, team collaboration roles in IT3090 is fundamental to be well structured in such way that there are not frictions and huge opportunities for the teams to work together. Life is about working as a team. This is a wonderful opportunity. Many of us as developers, we prefer to work by ourselves, but it's impossible. The problems, the IT problems that we solve are too large to do it by ourselves. So we need to learn that, and this is a wonderful opportunity that you need to develop strategies to work by yourself. Right? Thank you for listening to the first week of your lecture. It is very important you keep this in mind. The concepts we have learned, we're going to deep them during the practice in our lecture, but you have to come back to this video if there is something you want to learn further or use the material we have shared with you. See you in the classroom, and don't forget to always have an opportunity to contact with me if you need any questions or I can help you further.